All right, guys. So I am going to attempt to solve the cat problem. 90% of our problem is the way we were drawing the cat problem. We weren't drawing our vectors to scale and it was throwing us off. So without further ado, here's the cat problem. So example 2 says Erwin carries his cat around for a walk. He walks 25 meters west, 15 degrees north. So here's vector A. 15 degrees north is here. We know that A, the magnitude of A, is 25 meters, 15 degrees north of west. Sorry, you can't see that. Okay. Then 110 meters south, 40 degrees east. So here's 110 meters south, 40 degrees. We're going to call this side B. So vector B is 110 meters south, 40 degrees east. And it wants to know what the total displacement is. So when I've got my two vectors drawn with my two compasses, I'm going to connect them. And I'm going to draw my resultant vector. This is the vector right here that we're looking for the magnitude and the displacement of. All right. So the first step of the solving one of these problems is to use cosine law. All right. So cosine law says that c squared equals a squared plus b squared minus 2 cosine of c. So if this is little c, this angle right here is big C. So we need to figure out what this angle is. I can go ahead and fill in the rest though, so I am. I have c squared is equal to 25 meters squared plus 110 meters squared minus 2 cosine. We need to, or 2AB cosine C. 2, knew something was wrong there. A, B cosine C. So 2 times 25 times 110 cosine of this angle. Okay, so math tells us that if this is 15, this also has to be 15. So this is 15 and this angle is 15 degrees. And this makes a 90-degree angle. So to figure out this little chunk in the middle, I'm going to say 90 minus 40 minus 15. So this little chunk in the middle is going to be 35 degrees. So I'm going to plug that in to my problem. I'm going to get that C is equal to 90.66 meters. So I can plug that in over here. I've got 90.66. The next part of the problem is to use sine law to figure out the angle of displacement. So that's what I'm looking for right here. All right, so how are we going to do this? Okay, so we're looking for this theta. I just paused the camera and made some color charts because I was still having trouble working this and explaining it at the same time. So I worked it and now I'm going to explain it. This entire angle right here is theta. That's what we're looking for. So I can say the sine of theta, this entire angle, is equal to, or over 110 degrees. That's going to be right here. This is my 35. So sine law tells me I can say the sine of 35 over my 90.66. So I'm going to get theta is equal to 44. And I can look at this and tell you that that angle is going to be bigger than 44. So 44 is measuring this angle up here. So I can say a straight line is 180 degrees minus the 44-degree angle I got here is going to give me 136 degrees. So this entire theta is 136 degrees, and that looks about right. But that's not what I'm looking for. I'm looking for this little bitty chunk here, and I have it labeled B. So B is equal to my theta minus the 15 degrees here minus 90 degrees and I'm going to get 31. So I have all of theta. I have to subtract out these 15 degrees. I have to account for these 90 degrees right here. What I'm left with is going to be what this angle is. So I'm left with 31 degrees. So this angle is going to be 31 degrees. So therefore, Aaron's displacement is 91 meters south, 31 degrees east. I hope that helped.